And there's no song. And we're live. Okay. Damn. I want that. I want that to be more exciting. Oh well. Hello there. Welcome to another stream. How are you doing? Hey Cyan. Um, so yeah, I thought this would be an exciting one. It's something that I wanted to try, and I thought, why not do it on stream? So, gonna do it on stream. Hey, Bewilder Beast. Um, yeah, so what's the plan here? So, this also is gonna be like a test run for me for a workshop that I'm probably gonna do later this year, in February. And essentially, I wanted to make something cool with compute shaders, something that would be easy for beginners to follow, and something that could potentially give you a good idea as to how compute shaders work and what cool stuff you can do with them, at least uh, in terms of graphics and in terms of what I usually do with them, because you can do a whole lot more with them. But yeah, the plan that I was thinking about is something that I want to do for a while, and it is cell texturing. What is cell texturing? In case you don't know, cell texturing is a pretty common technique, pretty old one too, that was used mainly for grass, but also like fur and other, whatever strand-like texture you wanted to give. Not cell shading, it's shell texturing. Um, Essentially, it's a very simple process. You basically stack a lot of planes on top of each other, and you use like a noise texture or a more specifically made texture, which you use as a height map to clip each plane at its level. Hey, Admiral Roga, welcome, welcome to the stream. Oh, well, that's a raid. That's a big raid. Um, yeah. So yeah, some first aiders use that. Um, Hello, raiders. Yeah, and hey, Julius Trader. Welcome, and yeah, thanks so much for the raid. That's awesome. And just in time. I'm just getting started. Hey, everybody. And thanks for the follow, Gimborn Wolf. Yeah. So as I was saying, cell texturing is a technique where you essentially stack a lot of planes and then you just clip each one from the top down using some noise texture, and you can make it look like fur or grass or anything like that. But the cool thing is that I wanted to generate all these planes using compute shaders. So we can take any mesh as an input, and we can use its triangles to generate more triangles on top, and more, and then we can draw these procedural mesh with our own custom shaders, and we can do cool stuff. Uh, all right. Oh yeah, I remember. Oh, sorry, I didn't connect the nickname. Yeah. It was really awesome. Wait, I think I can find it. Hold up. Because I really wanted to share it. Okay. Can't find it now. I'll get them. Yeah, if you have any links to your Twitter or anything for people to see it, that'd be awesome. Because I cannot find the link right now. Is this VFX technique efficient? Oh, Oh, there you go, yeah. Oh yeah, such a awesome work. Thanks for sharing, Sibiraf. Yeah. Is it efficient? I mean, kinda. No, well, depends, because what you get with this technique is that you can cover whole surfaces with like dense, puffy material, and that's something that you cannot easily do with any other process. So it's relatively efficient for what it offers. But even if it's not really efficient, just the process of actually seeing how to use compute shaders for that and how to set this up, I thought it would be interesting. So I thought I would share it. Hey Dane, welcome. Am I dropping frames? No, I was just doing it choppily. Okay, never mind. Yeah, so it's all gonna be from scratch. Ignore everything you see here. So I first gonna make a C# script. So here is an unfortunate issue with this setup. Okay, so when you use a compute shader for procedural geometry like that, you end up not seeing anything in your screen unless multiple things work together and they work well. They will either work or they won't work. So we're gonna have to write plenty of code before we actually see something happening, and even then I cannot promise you that things will work, but yeah. Oh yeah, thread groups Z. I'm not even gonna use thread groups Y, I don't really have to do that kind of parallel thing. Why am I creating scripts in the scene? Okay, I'm a bit tired. So, I'm gonna call this cell texturing cell geo. Yeah, whatever. I don't have a better name for it. If you do, just let me know. Alright. So first thing I want to do, get rid of those. Here is the easy stuff. Alright, since we're gonna have compute shader stuff, there's some boilerplate that you can use in most of the whatever compute shader stuff you do, which is, you're gonna have to set up some buffers and you're gonna want to release those buffers. So something that I always do is, okay, make a function that is like set up buffers. We're gonna set up our buffers there. I think we're only gonna have to use just 2 buffers. One for the input triangles and one for the output triangles. Yeah, that sounds about right. Private void release buffers. And what I usually also do, because it's convenient, I have like buffer, and the process is usually, if it's not null, release and set it to null. Alright. Compute shader helper. Oh, that's cool. Create write buffer. Oh, that's really cool. Yeah, haven't looked into that. It's definitely handy because compute shaders have a lot of boilerplate code. Hey Raima, oh that's cool. I'm really glad you will enjoy this then. Hopefully, if it works. It will work. Something will work. I will generate some geometry here. So yeah, compute shaders have working with compute shaders has a lot of boilerplate code, for setting up the buffers, for making the buffers, releasing the buffers, and all that stuff. So having a helper function for that is like super useful. Then we will also have our compute shader, so might as well go and use that. So compute shader, rendering CS. I mean, it's not for rendering, it's for cell texture, GeoCS, whatever. I'm not good with names for this, because and yeah, I'm gonna need to. It's handy to have like an integer for the kernel ID, though that's, again, this is probably more like good practice, which is good to, you know, have some good practices, because the kernel, I will go ahead later and explain what the kernel ID is, but we might as well have it hard coded to be 0, because I'm just gonna use like the one compute shader kernel. I'm gonna use the thread group size, and yeah, that's it. Though just keep in mind, I also have a cheat sheet here because I can't remember everything, you know. All right, since I'm gonna be using the graphics DROMES procedural indirect method, I'm gonna be using, I'm gonna need some indirect arguments, which I will initialize to this. I will explain them later, maybe. 1, 0, 0. Come on, 0. All right, and hey Greg, welcome. So now I'm gonna need to make some structures that I'm gonna have to use to, well, organize my data a little bit. So I haven't tried this before because all the other stuff I've been using were taking vertex position as an input and generating triangles as an output. But here, it doesn't make any sense to use vertices as inputs, because I want to go to essentially make triangles from it. I can't explain it well, but the thing is, yeah, I want to make multiple triangles per triangle, not per vertex. So I'm gonna have to use the triangles as inputs. That's what I'm trying to say. So those int params are going to control some uniform in the shader. Not exactly. So give me 1 second. DROMES procedural indirect. So this is the documentation for the method that I'm gonna be using. So as you can see, there is it takes a compute buffer that uses some indirect arguments. Trying to find exactly if they're well, no worries, I can tell you what those mean. These arguments stand for the number of vertices per instance that we're generating, the number of instances that we're generating. This is gonna be 1, like it's 1 instance of this mess. The index of the vertex of the vertices that we're starting from, and the index of the instances that we're starting from. So these are all 0 and 0. This we're gonna change through the shader, through the compute shader. You will see how. But yeah, you're like jumping ahead. All right, so let's make some structures. Okay. So I'm gonna have to make the... Okay, let's do it like that. Let's public track. Gonna do it in a weird way, maybe. Not quite sure how this will work. So yeah, haven't used compute buffers, structure buffers, and compute shader texture. Oh, textures only so far. Yeah, yeah, compute buffers. I mean, the way that compute shaders use textures is actually really similar to how they're basically buffers. Textures are also buffers for the compute shader as well. Unlikely to vary this like an input. Yeah, these do not go into the shader. These essentially are arguments for the procedural generation to let it know, you know, how to generate this mesh. The final goal of this shader is to make cell texturing for grass or fur. So, in case you don't know, just find. Damn, I found. Yeah, if you Google cell texturing, you just get something from Nexus mods for Skyrim, I guess. I'm trying to find. Okay, let me see if I can find any good resource. Okay, this looks like a plenty good resource. I think this is using plenty of transparency, so I'm not sure if it's fast enough. But yeah, this is a process of cell. That's how it's called. So it's an old technique, as far as I know. So you know what? Yeah, screw it. I'm gonna. Will this work? You know what? Let's try this. All right. No, you know what? I don't like this. I don't like this. Input vertex. Yeah, I think that's better. So, well, the environment, if you click on the link I set up above, in case you weren't here, it's this one. It's a technique used for like fur and grass, which is essentially you stack a lot of planes together and then you dissolve each one at a level using a noise texture or some other texture. Okay, input vertex. So the things that I care about as input is like the triangle and especially the vertices of the triangle, obviously, because I want to make another triangle offset along its normals. So what I do want is the position and the normal and its UVs. That's all I want. Make those public. It's a bit. Oh, no, hair cards are a different thing. Hair cards is pretty much what you what it sounds like. It spawns little quads that are like cards on whatever areas you want hair on, and then you just add some texture, some hair-like shader on it, and that's how you get hair. Ooh, this is my time to shine. Wait, do I? Is it this one? Yeah. Alright, and the input triangle is just gonna have input vertex. Wait, can I? Sorry. Yeah, okay. Alright. Also, something that I need to add is this thing. Use system. There we go. So this will ensure that this the struct is being stored in memory like sequential, and it's sequentially, and that's good to set up the buffers. I mean, I haven't tried it without using it, but I've heard it's good, so let's stick with that. Okay, essentially I'm gonna need a buffer for these, just storing these. Meanwhile, sorry, I'm drawing a blank, so can I make this like a static array of 3, or do I have will I have to? Okay, whatever. Okay, so let's make the compute buffers. So the compute buffer is gonna have like the input triangle buffer. Though before that, I'm also gonna have to have a list of those input triangles. I'm gonna have a private compute buffer. This is gonna be the draw triangles buffer, and I'm gonna have a compute buffer for the indirect arcs buffer. These 3 compute buffers. All right. What's the size of it now? Okay, so input triangles stripe. So we have some floats here. How many are those? So we will have each input triangle object is gonna have 3 input vertices. So multiply that by 3 and multiply that by whatever size this input vertex struct is gonna have. So that's gonna be 3 floats for the position, 3 floats for the normal, 2 floats for the UVs. Usually I write those explicitly so that I know that this corresponds to this. Does that make sense? Again, for better readability and just encapsulate that all. Again, this is just for readability. Gonna have 3 vertices, each vertex gonna have position, normal, and UVs. Hey Angry Beam, expect that change appearance in VS Code. Well, there you go. As you can imagine, lots of people ask me about this. Oh, thanks for the follow. Oh, okay, good to know, Cyan. I actually saw that first from Ned Makes Games, sees videos. So yeah, that's where I got the habit of doing that. Alright, so that's a stride of the input. Draw triangles stride. Well, that's gonna be whatever data we want on our draw triangles. So it's gonna be whatever it is size of float. I'm gonna need a position. Again, this is gonna be multiplied by 3. So I'm gonna need a position. Probably gonna need the normal. Yeah, I'm gonna need the normal. Gonna need some UVs. I'm gonna need some vertex colors. You'll see why. And I think that's it. Group shared data. I'm not even gonna pretend I know what those are. I think I've seen something like that, Dane, but I'm not sure I've used that. Feel free to send a link about that. And the indirect args stride is gonna be 4 multiplied by the size of int. This is just like 4 integers. Easy stuff. So now we can finally have something to put in our setup buffers here. The input triangles buffer is gonna be a new compute buffer. Wait, I'm gonna need some more stuff. First off, mesh renderer, mesh filter for sure, and we'll see about the rest. So I'm gonna need some I'm gonna need the mesh as an input, right? So that's a given. Thanks for the follow, Peppers. So mesh is gonna be the get component mesh filter third mesh. All right. And just for ease, because I'm gonna be using that a lot, the triangle count is gonna be triangle count equals to mesh triangles All right, as I'm changing the window, somebody tell me if this is correct. Okay. Oh, oh, you're talking about the same video probably. Okay. Yeah, I will take a look at that. Anyway, fun fact: this is wrong. Not very intuitive, I think, for on account of Unity. So you would think that the array triangles would have the length of how many ever triangles the mesh has, but that's wrong. It's multiplied by 3, because this actually is an integer array of all the indices for each triangle. It's like weird. Yeah, it is an array of indices, exactly. Hey, Valerio. It's not very intuitive. Anyway, I've had issues with that in the past. So, okay, now I know triangle count. That's the input of the triangles that I know. The stride is gonna be the input triangle stride, and I can also add some extra sauce, just... yeah. So, compute buffer type is gonna be structured. And which I think is the default type either way, but yeah, whatever. And compute buffer mode is immutable, because I'm not gonna change this, I'm just gonna send it over. Now the draw triangles buffer, new compute buffer. So that's gonna be the triangle multiplied by, I'm gonna expose this, it's gonna get exposed. So public int layers, let's set this to be 1. Have a minimum of 1 layers. Yeah, that's divided by. Right? Yeah, it's divided by. Multiplied by layers with the... I've been saying multiplied. Oh, sorry. Divided by 3. Draw triangles buffer. Oh, sorry. Draw triangles stride, and that's gonna be a compute buffer type append, because we're gonna append triangles to that. And the indirect arcs buffer is gonna be new compute buffer 1, direct arc stride, and a compute buffer type of indirect arguments. And that's about it. Release those when the time comes. Release buffers, input triangles buffer, draw triangles buffer, indirect arcs buffer. Yeah, this should all be release buffer. Yeah, I mean, come on, Dane. Division is a multiplication either way. Alright, one also thing I want to expose is how high these planes will go. So yeah, actually, little known fact, division is only called division if it's from a certain place from France. Otherwise, it's just called multiplication. Yeah, feel free to tell your friends and quote me on that. Alright, release buffers. Okay. Alright, let's set up some data now. Yeah, I think it's a good place to set up some data. Okay, I'm gonna have to set up this data here. Okay. Private void set data. First off, because yeah. And the input triangles buffer is gonna be new. Oh, sorry, input triangles is gonna be a new list of input triangles. And now, for triangle count, thank you. Input triangles. You know what? I'm gonna make a constructor. Thanks for the follow, Peppers. Oh, wait. I thought that was you. Well, again, thanks for the follow. I'm gonna make a constructor, yeah. I'm gonna add... You know what? Wait. Wait, I don't want that constructor. I thought something was wrong. Yeah, I want that constructor. No, I don't want this. To do. Yeah. No, I'm not gonna make a constructor. I'm got bored already. No, you know what? I'm gonna make that constructor. I'm just gonna do this and be done with it. All right. So I'm making that list, and now thanks for the orbs. I should hydrate. Mesh dot triangles length. Okay, so this is where I get unreasonably confused. So the triangles divided by 3. Sorry, it's I divided by 3, so that's a triangle index. Not using a razor list. Yeah, it's one of those things that, you know, it used to be bad to use lists, but now it's not really all that bad. But it might still be slow. It's one of those things, you know. Yeah, arrays have a defined. I mean, arrays are by definition a bit faster, I guess, because they have a defined size and they don't have all the fancy functionality around them. They're more straightforward. But yeah, okay. So input triangles, triangle. Oh, okay. In vertices. Oh, also, yeah, that's something I forgot to do. Input triangles add input triangle. Okay, yeah, all right. So input vertices. Mod 3. Okay, so mesh vertex vertices. Sorry, I. Okay, figured that. I think normal and UV, and that's gonna be mesh normals I, and that's gonna be UV I. Hey Jane, welcome to the stream. Uh, yeah, I think that's it. I think that's it. Right. So I'm setting up. I'm making triangles. I'm taking it in the list. Why did async get added at some random points? Anyway, I'm adding it to the list. So I have a list of triangles. Vertex I mod 3. Yeah. I think that's it. I think that's how math works potentially. All right. Okay, so I have this gives me a nice list of input triangles to pass over to my buffers. That's cool. Let's do that. Generate geometry. Oh, the geometry. Okay, again, if the mesh is null, just get out. Just just get out. Okay, and or you know what? At this point, if also the cell texture geo compute shader is now also get out. And also, if the rendering material is now also get out. What's the rendering material? I haven't made it yet. Here's the rendering material. It's gonna be public. I'm gonna rendering material. Thanks for the follow, Ninja. Okay, okay. So now we go over to the cool stuff. Remember kernel ID? Let's get that. From cell texture geocs, find kernel. Gonna call it cell texture geo. It's pretty straightforward. Let's get the thread group sizes. So cell texture geo, it's kernel thread group sizes, kernel ID. Wait, it's still playing. Okay, I wasn't sure. Alright. Sorry, my cheat sheet. Okay. So our int thread group size is size X, and I don't care about the rest. Oh, thanks for that, Cyan. Good catch. Yeah, that would cause issues. Thread group set. Wait, what's wrong with you? Oh, it's uint. Okay, and the thread group size is gonna be the mathf still to int. Let it float. The triangle count, I'm gonna run this once for every triangle. Divided by the third group size x. Yeah, that's it. Okay, we have our basics to run our compute shader, but we have no data in the compute shader, so let's, add that. I'm gonna pass my buffers here, so set buffer ID. It's gonna be the input triangles buffer. Yep. Triangles buffer. Indirect arts buffer. Indirect arts buffer. Awesome. I'm also gonna need to know how many triangles I have, but that's easy to add. So let's set int. It's gonna be the triangle count. I'm gonna need to pass over the local to matrix, the local to world matrix, because we're gonna be in local space and we don't want that. So set matrix local to world. It's gonna be the local to world matrix. Some more information. So I'm gonna need to know how many layers I'm gonna have. So layers. I'm gonna need to know how high this is gonna go. So low. Oh, thanks for the follow, Seeds. Hide offset. All right. I'm gonna need to set the output buffer, so self-execute set buffer. Oh, and thanks for the follow, Jane. Kernel ID gonna be called draw triangles buffer, and it's gonna be the draw triangles buffer. Wait. Oh. Okay, sorry. That's because I wasn't thinking. Okay, so I will have to pass that buffer over to the rendering material. Sorry. So set buffer, and that's gonna be triangles buffer. And something I'm missing that shouldn't be. Okay, I'm doing that there. Yeah, alright, you know what? Let's do that there as well. So the input triangles buffer set data, get it from input triangles. Also, the draw triangles buffer, I'm gonna have to set its counter value because it's an append buffer over to 0 whenever I set up the data. It's gonna start from 0 because I append stuff to it. The indirect args buffer just set data from indirect args. Thank you. I'm gonna need some bounds, but for now, yeah, see, I did want the mesh renderer. Or wait, do I get the bounds? No, I don't get bounds from that. I need them from the mesh renderer. So mesh renderer here as well. All right. And since we got all that, I can go ahead and dispatch that shader. So dispatch. with kernel ID, with the thread group size on the X, but Y, one on the Y, one on the Z, and that's about it. And the final thing, obviously, is to actually render the thing. So, wait. Just gonna call graphics draw mess. Draw procedural indirect. Yeah. So rendering material. Again, if the rendering material is null, or you know what, a better way to do that. False. And yeah, when all of that's done, initialize was true. So yeah, if initialized, then go do your thing. Okay, so rendering material. What else? Bounds. We need some bounds. Mesh render.bound for now. I know this is not gonna work well. Mesh topology. Triangles, from what I know. Buffer with args. That's gonna be the indirect args buffer. Args offset 0, yeah, that's cool. Camera null. Material property block, yeah, that could be cool, but I don't really care about that for now. Okay, so let's add those explicitly, I guess. No. Shadow casting mode. Set that to false, and then maybe we'll do something about it. True, and layer, just use the same layer as the game object. Oh no, it's not true, it's Unity. Yeah, that's it. Let me I don't enjoy this syntax very much. It's very JavaScript-like, but it's handy for these kind of methods that extend beyond your screen. Again, why does it make it async? Do I do something that makes it async? It does it all the time. Anyway. Alright. That should do it, but if in case you haven't noticed, I haven't even wrote the compute shader. Oh, and also structs cannot contain explicit parameterless constructors. Oh god, it's explicit. Oh no. Okay. In that case, yeah, Dane, don't judge me. It's my shader playground project. I need projects that I don't care how the structure is, so that I can experiment. It's full of redundant tests and weird other stuff. Okay, so at least now it's compiling. Okay. Let's make the compute shader. Compute shader. What did I call the texture? The script, sorry. It's cell texture geo, cell texture geo. It's cell texturing, not cell texture, but now I'm named it like that. So, okay. this is my main kernel, the one I mentioned that I'm searching for here, yeah. Yeah, if I have no other dependencies on what I'm making, then I don't care about how clean the project is, because I'm just doing standalone shader experiments. Yeah. Okay, let's set that to be 64. And delete this and this. I don't need those. Alright. What I do need? I do need this. I do need this. I do need this. I need this and this and this and this and this. So, triangles. Local to word. Oh, come on. Layers. Hide offset. And no, I won't need that for now. Okay. Okay, so here's the thing. I'm also gonna have to make some structs here. Coincidentally, it's gonna be the same structs, really. So, without all the public stuff. This, gonna do this. There's no vector here. Don't float. We all float down here. It's gonna be this. And also I'm gonna need a struct for the output. The draw vertex. It's gonna have all these, but it's also gonna have vertex colors. I could use the same struct if I didn't want the vertex colors, but I do want the vertex colors. I do want them. And also the triangle. It's just gonna be draw vertex. Yep, just this. Okay, moving on. So this is gonna be a structured buffer of input triangle. This is gonna be an append structured buffer of draw triangle. This is gonna be an RW structured buffer of indirect arcs. Yeah, okay, I'm gonna have to make another struct. Vertices per instance. Instances, start vertex index and viewing start instance index. Okay. Then that's easy. This is an integer. This is a float 4x4. This is an integer. This is a float. Finally. Okay. One more thing. let's make a handy little method. This takes a position, and it also takes float 3 normal, float 2 UV, and you know what, float 4 color. Vertex output is gonna be vertex 0 for initialization, output position, world position 1, XYZ, okay. It's gonna be the same for normal, but it's gonna be 0 because it's direction. Output UV is gonna be UV, output color is gonna be color, turn output. All right. And now, so if we run out of triangles, we should probably just return triangle count. Okay. My triangle right now, input triangle is the input triangles buffer ID X, yeah, and I am gonna need to make some raw vertices. How many of those? Well, 3 multiplied by layers. All these. Oh, it's not gonna let me do that. Well, not the way I wrote it, but it's not. Vertex. Oh, just color. Yeah, it's not gonna let me do that. Okay, this is annoying. So I kind of want this to be dynamic. No, you know what? It's okay. It's okay. Yeah, it's okay. I'm gonna do it in a loop. Either way. So, let's go in our loop then. Yeah, for int I 0 I custom layers. I'm gonna be able to do that. Now make the raw vertex vertices. Make 3 of those, and well, the position essentially it's gonna be offset. It's gonna be the input triangle okay. Equals 0 to custom 3, I guess. Offset is gonna be the input triangle input vertices, I call it, yeah, vertices. J position well, the position plus the normal. Oh, thanks for the follow. Multiplied by the height offset multiplied by, it's gonna be note I divided by layers. Yeah, let's make that fluent too. I don't know. Awesome. You know what? I +1. Yeah, because that way the first one won't be right where the previous one was. And draw vertices J. Well, you get vertex with position and normal. Yeah, I do upload this on YouTube, and this will also be definitely uploaded as well, and you can see all the other uploaded videos here. Get vertex position normal and UV and the color. The color is gonna be actually the float for factor and 1. I don't know. Or I mean, you know what? Just I might want the other channels for something, but okay. So now I have my 3 vertices here. I can go ahead and make a triangle. I mean, I can make that here. I know this is 0 equals. Well, you know what? I could probably do it here. Oh, thanks, Daniel. Yeah, everybody's really helpful and friendly in there. It's really awesome to see. And now I can draw triangle buffer, append my triangle. Awesome. And I also finally have to update the indirect arguments. Indirect arguments buffer 0 num vertices per instance. Well, that's gonna be 3 multiplied by layers, however many layers we added. And that should be the compute shader. Again, if everything works, we still don't know, and I still cannot run it yet. What's up with that? Oh, did I call it just? Yeah, okay, draw vertices then, I guess. Implicit truncation and array reference. Okay, then I guess. Gonna be better for you? Yeah, okay. An implicit truncation. Where do I implicit? Whoa, that's a float tree. Okay, that should have been a body. Okay. No warnings, no errors. Compute shader. Okay. I can even go ahead and add the script. I mean, it's not running if it's not playing. New, so picture geo, and I can drop that here. And the final thing left, and I'm not gonna go crazy with this, is the shader, the actual object shader. So picture. I'm gonna start with an unlit version and then go from there, because again, there's no guarantee that anything will work at all. So here's the difference here. Instead of this thing, I don't really need this. Also, you know what? I'm gonna yeet the fog as well. So instead of this, I will have the vertex ID. Also, I'm gonna have to use a structured buffer like this. Hey there, welcome to the stream. But the awkward thing here is that I actually have to declare the same exact structs as in here. I mean, it's not a big deal. I can just copy and paste them. What I'm doing in other places is that I put these in a HLSL file and I include them both in the compute shader and the vertex fragment or surface shader or whatever, and you know, I can use the same structures there. And if I have to change something, then all the changes are synced. Okay, so I'm here and I need to get the triangle. The triangle is gonna be from the draw triangles buffer, the vertex ID divided by 3, and the individual vertex, well, vertex V, it's gonna be the try vertices, and it's gonna be the vertex ID multiplied by 3. So now I have the position here, so that's the position. I have the UV here as well. I also have the normals, but I'm not using them now, so let's forget about them for now. V.color. Yeah, that's what I want, the color. So I should probably add it here as well. Color. Oh, also keep those. Next color 1. Oh, I mean it's color. Is this compiling? It does not, because these are draw vertices, they're not simple vertices. Draw vertices. I don't know why I kept that name. Okay. Oh, and just to be able to see things, I'm just gonna return. I'm gonna multiply the color with the vertex colors, just so we can see things. Okay, after almost 1.5 hours of writing blindly into 3 different code files, let's see if this actually works. Ready? Can I get a drum roll? Or anything? This is gonna probably break in horrible ways, but let's go. Okay, it did not explode. Let's see what happens if I add 10 with high offset of 5. Not much. That's annoying. Alright, let's wireframe mode Unless they're really far away, which I highly doubt. Or they're really close, which I also highly doubt. Nothing seems to be happening. Well, that was a bust. Okay, let's see what's going on here. So, oh, well, I mean, if I don't actually call these methods, seems like they don't get called on their own. Like, this is such a weird behavior. I mean, I wrote the methods. Why didn't they call themselves? Jesus. Okay, I might not even run the compute shader, but it's there. It should run. Yeah, I know, right? And you know what? On validate, do that again. Probably. Oh, no, not that. Just that. All right. Take 2. Well, it still doesn't work. Okay, I got out of the. What's up? Wait, do I get that? Okay, alright. I'm getting an error. This is good. Input triangles. Okay, but why? Index was outside the bounds of the array, but okay, but oh, maybe this. Input vertices. Maybe this. Oh, hold up. Whoa, okay. Wait, okay, this is fundamentally wrong. Okay, all right. So yeah, I for some reason at that point I think I had in my head that the length of the triangles array is the same as the length of the vertex array, which is not the case. So this is the index of this. Yeah, this should be y. Okay. Let's try this again. Okay, more errors. Must be splittable. Oh, is it not splittable? The input triangle list. Apparently, it's not splittable. Yeah, no, sorry, Dane. Why is it not though? I think that was the point of making it destruct. Is it because it has an array? it might be because it has the array. Because it's a dynamic array and yeah, that was one of my concerns. So okay, let's do it the ugly way for now. Wait, what? Variable. Okay, why? Meanwhile, I'm looking through the. No, wait, no, I'm not looking through that. I'm so confused right now. Why was I able to do it before, but I'm not able to do it now? That was a C# error. I'm gonna do it like that. Fuck if I care. Yeah, I don't care. I'm doing it like that. Yeah, that means I'm assigning the same triangle 3 times. Yeah, getting a bit fuzzy on the details here, but yeah, freaking if I care. Okay, so let's change that over to be oh, I'm gonna have to. Guess I'm doing it like that. This is not confusing at all. I don't know what you're doing. Position vertex. Normals to vertex 1. Wait, because I'm also confused. Using statements in the loop. Oh, in C sharp. Oh, you're right. Oh, you're right. Okay, I thought that was off. Yeah, you're very right on that. Okay. Screw it. Just screw it. This is how it looks when a person gives up. That should be good though, right? I don't have the gray matter for this anymore. Let's see. It's working! Oh my god, it's working! A bit uncertain as to why I can't see them all, but it's... Well, kinda works. I'm definitely missing some layers. Okay. This should help seeing things. Meanwhile, why does the layers... Right offset, clipping it. Yeah, exactly. It only renders 1, 2, 3, 4, 5, 6, 7, 10. These are 10. Why are they 10? What makes them be 10? Yeah, the height offset is actually like the total of how high this will go. We have to change that dynamically because the buffer is already... Oh, that's why it's 10. Yeah, that makes sense. Yeah, that makes a lot of sense. Yeah, because okay. Yeah, that makes a lot of sense, Ian. You make a lot of sense. Yeah, boy. All right. Thick layers. And I mean, yeah, it's a nice stack. It doesn't get updated though. We can fix that. Maybe if we want. But I also want to check. Attempt to create zero length compute buffer. Where? Triangle count. But it has triangles. Anyway, what if that wasn't a quad? And what if that was actually a sphere? Yeah, for all we know, that seems to work. So, yeah, okay. Alright. Yeah, that took me a while, but okay, alright. Height offset 0.2, 30 layers. How does that look? Okay, looks good. I think I'm gonna need more. Yeah, 200, 0.2. That should be good. All right, so the cool thing about this is that I can now play around a bit with this. So let's add a noise texture, like a weird cloud noise. That should do. Okay, and what I wanted to do, it's pretty simple, and this is why I really wanted those vertex colors. It's because okay, I can get that. You know what? Add some color to it. And return that. Oh, that. Okay. And I can now say tag clip text minus, well, the color code X. So now if I hit play, I get this. It's a weird kind of volumetric effect, I guess. Not very grass-like, but we can change the textures and we can get some nice, cool results. Or fluffy results. Or sandy results. I mean, it's one of the ways to get some sort of. Oh, actually, give me 1 second. I will be right back. Sorry. And I'm back. Okay. Yeah, I was saying that you can use a bunch of different textures. I'm trying to find something that can look mildly like grass. This can look mildly like grass. Kinda. And you can get something really fluffy looking. Which is cool. And also might as well uh, yeah, do the whole transform text thing. So it can be even more grass like. Can even do like weird shapes like that. And you know, because it's a gradient, the vertex color gradient is used for this clip. You can also control the fall off and maybe use like some kind of exponential curve, so it's not that fluffy. So it's not that abrupt if you want it to. Okay, what's a good texture that works well with this? Oh, that works well. Yeah, this looks fuzzy enough. Yeah, I could roll around that. Okay. Let's try and make this lit now. So, texture geo lit. It's gonna be fairly easy. So I'm gonna have to copy over these here and this as well over to a surface shader. I'm gonna need to add some of these though, because it doesn't work without them. How fun is that? Add some shadow, and also I'm gonna need a vertex method. Let's make that. Output. Do I have that? Oh yeah, I have that. So I'm gonna make the app data struct myself. And yeah, the reason for that is so that I can throw it over to whatever surface shaders do under the hood to calculate all the normal stuff and all the whatever else we might need. So this is gonna be the position. Gonna need the text code. I think that it won't let us rest until we give it 2 other channels, so might as well do that. The 3 normal, and of course the vertex ID. And in here also I'm gonna need the out input O. And again, same thing with the if def here. So triangle is gonna be the from the raw triangles buffer, the output ID, and the raw vertex v is gonna be the try vert raw vertices output ID mod 3. So this is gonna be the float for v dot position 1. Normal is gonna be v dot normal. I've already made it so that it's in wall space, so that's gonna work alright. And text chord tools v, and I can go ahead and do that for 1 and 2. And finally, after all that, I'm gonna say unity initialize output input O. And well, I'm gonna give that the albedo color B. And let's say clip text minus well, if I want the vertex color, I can just get it from here, like that, I think, in color. Doesn't know what C is. Yeah, that's 1. So the shade is the float for. What was up with that? Need to have a. Oh, well, I didn't assign the color, of course. Oh. Right. So let's change this to use the cell texture lit, the same colors and properties, and let's see how that looks. Well, thanks for the follow, Nicholas. It doesn't look good. Zero length buffer. Why are you lying? Yeah, it's working with the unlit version. Doesn't work with the lit version. Okay. Let's see if anything at all works. Okay, this is the lit version, seems to be working. Okay, so something with the clipping. Okay, just no, I mean, okay, I can say .x, but all right. So one super annoying thing about this, which you can probably already can tell, and let me also multiply with text here, is that okay? Yeah, we do have the grass and all that, but obviously the normals don't follow the noise, which is obvious because yeah, the normals are still the normals of the terrain. But the cool thing is, and let me confirm that, yeah, we still get shadows, cool little shadows, which is cool. Yeah, look how fluffy this is, so fluffy. And if I go back over here and change that to be on, yeah, it's very fluffy. That's the cool thing about cell texturing, is that, you know, you go all the way, it's like super fluffy. Yeah, I just need public pool, shadows to false. Hey Zach, is this style cross pretty performant? Well, relatively speaking, in, you know, cause oh, that's because of the on enable. Okay, let me on validate. Sorry. So I can. So relatively speaking, I guess, because if you wanna spread fluffy grass across a really huge surface, I guess this is one of the better ways to do that. Oh, no worries, like, but yeah, so it's one of the better ways if you want like fluffy grass all over. This can also be done, by the way, with geometry shaders, which I would think wouldn't be very performant, but I actually tried Brute Force's grass, the one they use on their game too, and it's pretty good. Okay, so what if I... Yeah, there we go. We've got some shadows. We've got plenty of shadows. Alright. Oh, we're dropping frames too. I mean, even with shadow casting... Okay, let's... Okay. Alright. Yeah, sorry. It's not as bad as it looks on stream. Yeah, stream doesn't like... My stream doesn't like my grass in general. Every time I'm sowing even like a few blades of grass, the stream does not enjoy it. And it's not like it's so heavy, really. Yeah, could it be? Yeah, it could be the compression, potentially. That makes plenty of sense, to be honest. Yeah, fluffy grass that receives shadows, and if you're not streaming, it can also cast shadows. Uh, and also, yeah, of course. I mean, let's try this out on a sphere. All right. How does it look? Some of the color in this grass texture. Uh, hmm. Well, it could potentially look like that. Yeah, that actually looks pretty cool. It's actually cooler than I thought it could look like. Let's. Whoa. Oh, the compression will not enjoy that. Yeah, the preview window does not enjoy it. If I change it to a cube, no. Plane, nope. Nope. Donut, a plane, nope. Actually, yeah, that makes sense. You know what? Why that makes sense, right? For the preview window to be weird. Oh, I did move the. Whoops. Wait, what time? Oh, I moved this. Oh, okay, that was weird. Sorry about that. But yeah, the preview window does look weird, but it makes sense because I'm essentially saying, okay, screw whatever you're doing with your own vertex IDs. I know what order your vertices are in, and I'm gonna use them as I like. So yeah, it actually makes a lot of sense. Like if I actually grab like a sphere and put that there, yeah, it's gonna go bananas. Something else I wanted to do. Yeah, okay. I remember. Let's go back to our plane, to our quad. Sorry, because that was just a quad, by the way. So even at 100 layers, this is 200 triangles. It's not all that many. Anyway, yeah. So one annoying thing about this. Well, first off, chill out with this. Okay. The bounds are a bit crazy. Which makes total sense because I'm currently using the same bounds as this mess here, and I shouldn't. I should expand on those bounds. Bounds. And here where I set up the data, I can go ahead and say bounds equals mesh render bounds. And I can say bounds expand. Well, I can expand by the height offset. Though that expands in all directions. There could be a more sophisticated way to do that. But I'm not gonna bother. Also, yeah, I can expand vertically only. in case you missed it, it can also take a vector 3. So you can just say yeah, exactly. That's the issue, as I described. That's why I'm not doing it just vertically, because on a sphere it's not just vertical, or on a big terrain. It's along the normals. Um. Okay, I can do the mesh height offset, but it's wrong. It's wrong. Why is it wrong? Because this is in object space. Screw it. You know what? Yeah. Sorry, I'm not gonna bother with the bounds right now. Because it's getting late and I should also probably eat something. Okay, something else though that I wanted to do. Because it wouldn't be grass if it's not moving. So let's make it move to make it grass. Yeah, I'm gonna do it the same way I do it always. So displacement amount. It's like my go-to. Could displace the texture. But now let's do it in the vertex shader. Makes more sense. Yeah, it does make more sense. Okay. Texture. Is that only for grass or any axis? Actually, that's a. You know what makes. You really pointed out something there. Okay, so instead of doing it there, let's do it here. No, it'll be placement texture, and you know what? Use the for like your since the look of the grass is driven from the texture, displacing the textures should look as if I'm displacing the grass itself, right? I mean, that kind of works, though it's a fine balance. Also, I should probably, yeah, drop that. Yeah, and you can see that it does, because of, it's not actually displacing the vertices, it's not moving past the edge. And this, sorry. Oh, okay, I have to. So it would work better with vertex displacement if I was planning to only keep it like on the XZ plane, but that way, this can also work on a sphere. Hill rather than a plane with. But it was rotated a bit. Don't know if, like, nervous grass. Does not like undoes. Okay. Vertex been along tangents by tangents. Well, I could derive. Well, if I had the tangent, I could derive the bitangent, but I could not. But I mean, I could easily generate those because I can get the tangents from the original vertices. These are stored in the mesh either way. So I could get these, and then I could get the bitangent. Also, did I move something else? No. Okay. No, I did move. Yeah. What's up with? Okay, I moved everything apparently. Where's my face? I lost my face. Not that face. The other face. Or did I not have the face there? No, it should have the face. Yeah, now my face is there. Okay. I'm gonna fix that later. But yeah, whatever. Oh no. Yeah, it's could be from Avatar the Last Airbender. Okay, this is a way more chill. Hey, Resin, welcome. No, it's not geometry shaders, it's compute shaders. It could be geometry shader, but it's actually made with compute shaders. Like, you can see, because I'm not generating the mesh every frame, like this is getting 1.4, 1.5 ms. Because I'm only generating it once, because I'm doing the, you know, assumption that terrain doesn't move. Slowly making geometry. Yeah, bewilder based. It's true that compute shaders are in general better than geometry shaders, or at least that's what I've heard, but I haven't done any profiling on the matter, any proper profiling. But it's true that you can essentially do anything you can do with geometry shaders. You can do that with compute shaders, though getting back and forth from like the realm of CPU and going back to GPU, I know that's usually Jesus, I messed this up. That's usually what makes things slow, while, you know, geometry shaders at least are just in the GPU and that's it. So for some cases, yeah, it seems that compute shaders are, yeah. Yeah, it's actually very similar to the crumble technique. Well, yeah, it's the crumble technique. It's the grass from brute force that I mentioned. Is using this technique. It's called cell texturing. It's a pretty known technique and it's pretty used for like grass or fur. Oh, that's cool. But I was actually surprised to see that the grass in Crumble, or at least the grass that Brute Force is selling on the asset store, is using geometry shaders. So apparently they can be used in other platforms as well. I thought that there were many platform restrictions with geometry shaders as well, but turns out that they're not. I don't know. Yeah, Metal doesn't accept geometry shaders. Though I think that on the asset that Brute Force is selling, they claim that it works on Apple. I think. I'm not sure. But yeah. So yeah, this is no geometry shaders. This is just a very quite basic, really, surface shader with some added stuff to get access to the vertex ID in order to access the buffer of the triangles that I'm generating. But yeah, no geometry shaders at all. Geometry step on that asset is just optional for world space subdivision of message. I'm not so sure. Alright, Jane, thanks so much for joining. I hope you enjoyed. I'm gonna put it's in a gist. Yeah, I could add like a generic surface shader for procedural geometry that, you know, in case you're using vertex IDs, because I had trouble with that too. I found it on some Unity forum that I had to do the these if def tags to make it work. Well, thanks for the follow, Adam. So yeah, this is fun. I mean, with this technique also you really don't want to go too close, but it's fun. It's working nice. And yeah, my assumptions were correct about how this could work. So I'm slowly getting better at compute shaders myself. Yeah, okay. Yeah, let's keep it like that. Oh no, okay, I cannot undo. It doesn't like undoing. Oh really? Switch is good at compute shaders. Good to know. Should I ever develop for the Switch? So yeah, this was pretty successful. It was not in the time frame that I would want for that workshop that I'm getting ready, but I mean, um, sorry, give me 1 second. Yeah, it's not for the length I would want for the workshop, but I mean, I was fumbling around, so probably it won't take me as long in that workshop. Oh, yeah, I've heard that compute shaders in Unreal aren't all that easy to use, but I just saw uh, a good, if I can find it, tutorial from Arnau about using compute shaders in Unreal. Um, which could be useful for anybody who uses Unreal's and Unreal Engine and is interested in compute shaders. Yeah, all right. So I think that is it for this. But since you're all here, I wanted, and since I have this project open, I'm gonna save this. Since so texturing. Okay, since you're all here, I wanted to give you a sneak peek of something that I've been playing around with, which is gonna get assembled all in the end, and it's gonna be great, I hope. You know what? I'm just gonna start with this. So I was doing some research into how to do some cool ripples on water, which I was already doing in the past, but now I can do it properly. So these are all right to the normal texture, and I mean it's nothing. That's nothing really new. All right, I'm just drawing some ripple particles, and in this shader I can I essentially just get the normal from the height information of the render texture with the particles. So yeah, that's the one thing. That's one thing, and then the other two things is something that I want to do for a while, which is, I mean, it wasn't that hard, but I just didn't know how to do it. That I can drop shadows of different things that you actually see. So this is actually transparent, but I can drop a shadow like this, which means that I can have like an anime style foam, or like you know, the type of water texture that also drops a shadow, even if it's not all that visible on the surface. But yeah, the more exciting thing is, as Dane mentioned, the SDF thing, which is this one here. Yeah, it's also running, like, I wasn't planning on having it real time, but it's running pretty fast on real time as well. I mean, the texture is 256 by 256, and yeah, it basically notice no hiccups when using it. And yeah, I can get this this pretty little SDF texture and do some really cool intersection water foam stuff with it. And yeah, I don't know, I got excited with this. And when I go to put this all together, I am going to share it with you. Oh, okay. The flickering comes from. So this is an issue that I was encountering with this approach that I ended up doing, is that if you're using, if there's like any other object intersecting, it affects how the SDF looks, because what the camera sees now is essentially it's drawing the outer face is black and the inner face is white. So since this plane is, this side is rendered black, if it's intersecting with this, it's rendered as it covers it in the camera, if you can see here, which is a bit annoying, and I want to fix that. But anyway, that's a sneak peek for some future stuff that I'm thinking about. 3D and sign distance field. Oh, that's cool. Yeah, I'm relatively new to that stuff. Definitely struggling to even understand how this jump flood algorithm works to even get this SDF information. But I'm happy that I can do cool stuff with it, so look forward to more. Oh, of course, K0. This is field generated. Oh, that's cool. Alright, yeah, that's... So it's a ton of breakers. Sounds about right. I wonder, is it also using like volume sampler? Okay, whatever. Yeah, VFX Graph also comes with like a SDF generator, which is cool. But yeah, I still got excited about this. Okay. Alright, so yeah, I think I will leave it here. This was a pretty successful experiment. I didn't know that I could pull it off, but we got some cool little compute shader generated grass or fur or whatever. Yeah. Effective. Yeah, that's the thing. Also, 3D textures are like expensive. They get big real quick. Yeah. Alright, yeah, that's about it. So thanks so much for joining and for sticking around, especially if somebody came from the raid. That was pretty cool. And yeah, hopefully won't take too long until I stream again. So yeah, I'll see you in the next one. Bye bye.